Hi students, welcome to Math Workshop. Before we start the class, please subscribe my channel first and click bell icon for regular updates. In previous classes, we studied about the concept related to relations. So in this class, we are going to study about a new topic, that is functions. So what is mean by functions and what are the types of functions? So in 11th standard, you already studied about the concept behind this functions. So let's recall that function topic. So first we need to know what is mean by function. So function is nothing but a special type of relation. So we already know what is mean by relation. So function is like relation only, but there is some rule that follows a relation. So function is simply a special type of relation. So this is the definition given in the book for function. So before we study this definition, first we need to understand the basic idea of function. Okay, so let us take one example. By this example we can understand what is meant by function. So first, this is a one relation. So first values are represent the first set, that is x. I will take as x. Second set is y. So first values denotes x, second values denote the y. So in function we represent by using one diagram. Okay, so this is x set, this is y set. In this, x means the first values in this pair. So 1, 2 and 3. This is 1, 2 and 3. This is second set y. First set x. Okay. So here 1 and 1 is relation. So 1 is related with 1. 2 is related to 2. 3 is related to 3. So this is the example of function. So this R is a function. So function is nothing but every x value should be associated with only one y value. So in this example, this one x value is associated with x only. Okay, sorry, y only, this one only. So every x value should be associated with only one y value, that is called a function. So here 2, this 2 is the x value, right? So 2 is associated with only one value in the y function, right? So every x value is associated with only one y value, that is called a function. So in this example, let's take this example. So this is x, this is y. Okay, so first element is 2, 3 and 4. 2, 3, 4. Here 2, 3 and 4. Here 2 is related with 2, right? So 2 is related with 2. 2 is related with 4. 3 is related to 3. 4 is related to 4. Is this a relation, is a function? No. Why? Because this 2 is associated with true values. Right? This 2 is associated with 2 and 4. So this relation is not a function because one x value is associated with true y values, because that is not a function. So function is nothing but every x value is associated with only one y value. Now we will read the definition. So a relation f from a set A to set B. So here it is represented A and B. Here it is represented X and Y. Okay. So two sets A and B. So what is mean by function means is said to be a function if every element of set A has one and only image in set B. So image is nothing but the second value. Okay, so every element in set A was only one image in set B. So this is called a function. So this function is represented by f colon A tends to B. So it is represented by this expression. Okay, so function is nothing but every element in set A has only one image in set B. Next, we are going to study the types of functions. There are three types of functions. So, first one is one-to-one. The other name of one-to-one function is an injective function. So, second one is many-to-one function. Third one is on-to function. Other name of on-to is surjective function. Okay, so let's see one by one. So, first one is one-to-one function. What is mean by one-to-one function? So, we will understand this concept by simple example. So I am taking two sets. Okay, one is X set, one is Y set. This is X set, this is Y set. Okay, so this X set consists of four elements A, B, C and D. This Y set consists of also four elements A, B, C and D. So this function is a one-to-one, means each value in the set X is mapped with unique element of another set. So A should be mapped with A, B is B, C is D, D is C. So this function is a one-to-one function. Why means this image of distinct elements of X under F are distinct. So distinct means different. So one-to-one function means each element in X is mapped with unique element of another set. So this function is called one-to-one function. For every one value in set X is associated with one value, any one value in Y. Okay, this is the one-to-one or injective function. So next one is many-to-one. So many-to-one means two or more elements of X is mapped with set Y. For example, this is X, this is Y. So 1, 2, 3, 4, 5, 6. So this is many-to-one. So many-to-one. So 1 can be mapped with 4. 2 also can be mapped with 4. 3 is mapped with 6. So this is an example for many-to-one function. So many-to-one function means two or more elements of X to map with a single element in set Y. This function is called many-to-one function. For this one-to-one function, there is one mathematical expression is available. That is f of x1 is equal to f of x2. This x1 and x2 is belongs to this X set. Okay, so we need to prove whether the function is one-to-one or not. We need to prove this formula. F of x1 is equal to f of x2. So x1 and x2 is nothing but the set X elements. So in this f of x1 is nothing but the output function. This is output function. This is input function. These elements are represented as input. These elements can be represented as output. So for a one-to-one function, you need to remember this expression. F of x1 is equal to f of x2. We need to prove this expression for one-to-one function. So the x1 and x2 are nothing but the set X elements. Okay. Next, what is mean by onto function? So a function f is said to be onto if every element of y is the image of some other element in X. So what is mean by onto function means if every element of y is the image should be a image of some other element in X. For example, let us consider this function. So this X value consists of A, B, C and D. Y set consists of A, B and C. So here in this Y values, A is mapped with A and B. B is mapped with C. So B is the image of C. C is the image of D. So every element of Y is image of some element. So this function is a onto function. Let us consider this example. So here in this Y set there are four elements 1, 2, 3 and 4. So this 1 is the image of X and Y. 2 is the image of Z. 3 is the image of W. But 4 is empty. 4 is not an image of any other element in X. So this function is not onto function or not surjective function. So onto function is simple. Every element of Y is image of some other element in X. So this function is called onto function. So it is represented by a mathematical expression f of x equal to y. So we need to prove f of x equal to y for a onto function. This y is belongs to this y. Okay. So we studied about the concepts behind the type of function. So now we know what is mean by one-to-one function, many-to-one function and on-to function. So let us see some examples given in the book. So first question, prove that the function f r tends to r is given by f of x equal to 2x is 1 to and on to. So we need to prove the given function is 1 to 1 and on to function. So this r tends to r means this x and f of x values are a real numbers. R represent real numbers. Okay. So first we will write the given equation f of x equal to 2x. This is the given function. So we need to prove this function is a one-to-one function. So what is mean by one-to-one function? Each element in the x having unique image of y, right? So for example, if we take this is x, this is f of x, right? This is x, this is f of x. If we take x as 1, f of x is 2 into x, that is 2. If you take 2, that is 4, right? If you take 3, that is 6. So that is map. So every unique element is associated with unique element in f of x. So this function is one-to-one function. Otherwise, we can represent by using the mathematical expression. What is the mathematical expression for one-to-one function? If it is one-to-one means f of x1 is equal to f of x2, right? So here f of x equal to 2x. So what is mean by f of x1? That is 2 into x1 equal to 2 into x2. So 2 cancel, x1 equal to x2. So it nothing but this function is 1 to 1. So we proved the given function is 1 to 1. Next we need to prove this function f of x equal to 2x is a onto function. So we will take f of x equal to 2x. So this x values are real numbers. So it should be a decimal number or a minus, plus, anything. It all under real numbers, right? So if I take x, this is f of x. So x should be 1, 1.5, 2, 2.5, 3. So f of x equal to 2x means 1 into 2, 2. 1.5 into 3, 4, 5, 6. So these are the real numbers. So this is mapping with this. So all the elements of this y should be an image of some other element in the x. So this function is onto. So by mathematical expression, we need to prove onto f of x equal to y, right? So here f of x is equal to 2x, right? So here two variables x and y. This x and y are the real numbers, right? If y belongs to real numbers means y by 2 also belongs to real numbers. Y belongs to real number means y by 2 also belongs to real number, right? Y is equal, for example, y is equal to 2 means 2 by 2 is equal to 1. 1 is also a real number. So y by 2 also a real number. So by taking x is equal to y by 2, 2 into y by 2. So 2 cancel, equal to y. So f of x equal to y. So hence this function is onto. So we prove that the given function is 1 to and onto by using some visual explanation or this mathematical expression. Okay. Second example, show that the function f tends to f colon n tends to n given by f of 1 equal to f of 2 equal to 1 and f of x is equal to x minus 1. For every x greater than 2 is on to but not 1 to 1. So we have to prove the given function is on to function but not 1 to 1 function. So given this values are a n. So the n is denotes the natural numbers. So the values are natural numbers. Give here f of 1 equal to f of 2 equal to 1. This is given. So f of x is equal to x minus 1 for x greater than 2. Because if x is equal to 1 means f of 1 equal to 1. X is equal to 2 mean f of 2 is equal to 1. So this is given. Okay. So here x and f of x. So by denoting a visual representation. So x, this is x values, this is f of x values. So what is given? 1, 2, 3, 4 like that. So f of 1 is equal to 1. F of 2 is equal to also 1. So this is given, right? For x greater than 2, that is f of, for example, x is equal to 3 means f of x is equal to x minus 1. So 3 minus 1 is 2. So 3 is 2. 4 is 3 like that. So is this function is a 1 to 1 function? No, because this 1 is associated with 1. 2 is also associated with 1. So this is not unique, right? So 2 should be associated with any other element. But 2 is associated with 1. 1 is also associated with 1. So this function is not 1 to 1. Why it is not 1 to 1? F of 1 is equal to f of 2 is equal to also 1. So this function is not 1 to 1. Next we need to check the function is onto. So for a onto, this is x, this is f of x, right? 1 is denoting with 1, 2 is also denoting with 1. 2 is mapping with 1. 3, if x is equal to 3 means f of x is equal to x minus 1. So 3 minus 1 is 2. So 3 should map with 2. 4 should map with 3. 5 should map with 4. So it will be goes on. So in this function, every element of this f of x is a image of some other element, right? So this 1 is a image of 1. 1 is the image of 2. 2 is image of 3. 3 is image of 4. So every element of f of x should be a image of any other element in x. So this function is onto function. So we can prove this function is onto by using that mathematical expression. For onto, we need to prove f of x is equal to y, right? So here f of x is equal to x minus 1. So if x belongs to natural numbers means y is also belongs to natural number, right? So if y is natural number, y minus 1 is also a natural number. For example, y is equal to 3 means y minus 1 is 3 minus 1, 2. 2 is also belongs to natural number. So y minus 1 is also a natural number. So by substituting x is equal to y minus 1, sorry, y plus 1. Right, y plus 1 is also a natural number. So by substituting x is equal to y plus 1 minus y is equal to y. So f of x is equal to y. So this function is onto function. So we can prove by using this diagrammatic representation or using this expression. Okay, so today we saw two examples of this types of functions. So I hope you understood the concept behind this types of function, that is one to one, many to one, and onto function. So in next class we will see the exercise problems. Thank you, students.